Imagine this: a spacecraft far from home loses its way. The vastness of space is both awe-inspiring and terrifying. The spacecraft, once a beacon of human ingenuity, now drifts aimlessly, a tiny speck in the infinite cosmos. It is adrift in the vast expanse of space. The stars, once a source of wonder, now seem indifferent to the plight of the lost vessel. The crew can only watch as Earth, a distant blue marble, shrinks with each passing moment. The home they once knew becomes a mere dot, a reminder of what they might never return to. This is the nightmare scenario every astronaut prepares for but hopes to never face: becoming stranded in space. The isolation, the uncertainty, the sheer vastness of the void can be overwhelming. Such a situation, while terrifying, is not entirely outside the realm of possibility. Space, for all its beauty, is an unforgiving environment where even the smallest error can have catastrophic consequences. Space exploration, for all its marvels, is inherently risky. The brave men and women who venture into the cosmos do so knowing the dangers that lie ahead. Astronauts are exposed to various dangers, from equipment malfunctions to the unpredictable nature of space itself. A minor glitch can escalate into a life-threatening situation in a matter of moments. While space agencies like NASA have numerous safety protocols in place, the question remains: what happens if a spacecraft is unable to return to Earth? The unknowns are many, and the stakes are incredibly high. What are the risks involved, and what escape plans are in place to ensure the survival of our cosmic pioneers? The answers to these questions are crucial as humanity continues to push the boundaries of space exploration. Space is an unforgiving environment, a realm where the slightest mistake can have catastrophic consequences. Unlike the protective embrace of Earth, it offers no second chances. The vast emptiness of space is both beautiful and perilous. The dangers are many, each posing a significant threat to human life and the integrity of spacecraft. From the smallest micrometeoroid to the largest solar flare, every element in space can be a potential hazard. One of the most immediate dangers is the vacuum of space. This vacuum is a silent killer, invisible yet deadly. Without a spacesuit, an astronaut exposed to this vacuum would face a gruesome demise. The human body is not designed to withstand such conditions. Lack of atmospheric pressure would cause their blood to boil, and the absence of oxygen would lead to rapid suffocation. The spacesuit is a lifeline, a barrier between life and death. Then there's the issue of extreme temperatures. Space is a place of extremes where temperatures can swing dramatically. Space can be both incredibly hot when exposed to direct sunlight and bitterly cold in the shadows. These temperature extremes can wreak havoc on both human bodies and spacecraft systems. A spacecraft's thermal regulation system is crucial for maintaining a livable temperature for the crew. Without it, survival would be impossible. And let's not forget about radiation. Space is filled with high-energy particles that can penetrate living tissue and cause serious damage. Unlike Earth, which is shielded by its magnetic field, space is awash with harmful cosmic rays. These rays are a constant threat to astronauts. Prolonged exposure to these rays can lead to various health problems, including radiation sickness and an increased risk of cancer. Protecting astronauts from these dangers is a top priority for space agencies. Space exploration relies heavily on complex machinery. From the engines that propel spacecraft to the life support systems that keep astronauts alive, every piece of equipment must function flawlessly. Even a minor technical glitch can have catastrophic consequences in the unforgiving environment of space. Imagine a malfunction in the life support system, responsible for providing breathable air and regulating temperature. Such a failure would quickly turn the spacecraft into a suffocating, freezing death trap for its inhabitants. Similarly, a problem with the propulsion system could leave a spacecraft stranded in orbit, unable to return to Earth or maneuver away from potential dangers. In such a situation, time would become the enemy, as fuel and supplies dwindle with each passing day. The vastness of space might seem empty, but it's actually littered with debris. This debris, ranging from defunct satellites to tiny fragments of exploded rockets, poses a constant threat to operational spacecraft. Even a small piece of debris, traveling at high speed, can cause significant damage upon impact. A collision with a larger object could prove catastrophic, potentially crippling a spacecraft and endangering the lives of those on board. This danger is not theoretical. In 2009, a defunct Russian satellite collided with a functioning American satellite, creating thousands of pieces of debris. This incident highlighted the very real threat space debris poses to our presence in orbit. Section 5. Houston, we have a problem. NASA's emergency protocols. Given the inherent risks of space travel, NASA has developed comprehensive emergency protocols to deal with a wide range of potential scenarios. These protocols are designed to ensure the safety of astronauts and, if possible, salvage missions that encounter problems. At the heart of these protocols is Mission Control Center, located at Johnson Space Center in Houston, Texas. Staffed 24/7, Mission Control maintains constant communication with spacecraft in orbit and beyond. In the event of an emergency, communication is key. The astronauts on board the affected spacecraft would immediately report the issue to Mission Control, providing as much detail as possible. Once informed, Mission Control would spring into action. Teams of engineers and experts would analyze the situation, working around the clock to develop solutions and guide the astronauts through the necessary procedures. This collaborative effort is crucial for addressing emergencies effectively. The protocols cover a wide range of potential issues, from technical malfunctions to medical emergencies. Each scenario has a predefined set of steps to follow, ensuring that no time is wasted in critical moments. Training is another vital component. Astronauts undergo rigorous training to prepare for potential emergencies, practicing various scenarios in simulators that mimic the conditions of space. This preparation ensures that they can respond quickly and effectively when real emergencies occur. The coordination between astronauts and Mission Control is a testament to the meticulous planning and dedication of NASA's teams. The ultimate goal of these protocols is to safeguard human life and ensure the success of the mission, no matter the challenges faced. Through constant vigilance, rigorous training, and seamless communication, NASA's emergency protocols stand as a cornerstone of space exploration safety. Section 6. Escape from orbit contingency plans for stranded astronauts. While NASA strives to prevent emergencies, it also recognizes the need for contingency plans. In the event a spacecraft is unable to return to Earth, escape plans and rescue missions would be activated. One such plan involves the use of the Soyuz spacecraft, currently docked at the International Space Station. The Soyuz serves as a lifeboat, capable of carrying astronauts back to Earth in case of an emergency evacuation. However, for missions beyond low Earth orbit, such as a journey to Mars, a Soyuz escape would not be feasible. In such scenarios, NASA is exploring alternative rescue options, including the possibility of sending a separate rescue spacecraft. Section 7. Learning from the past. The Apollo 13 crisis. The importance of robust emergency procedures is best illustrated by the Apollo 13 mission. In 1970, an oxygen tank explosion crippled the Apollo 13 spacecraft en route to the moon, jeopardizing the lives of the 3 astronauts on board. Faced with dwindling oxygen, limited power, and a damaged spacecraft, the astronauts and Mission Control worked tirelessly together. They devised ingenious solutions, using duct tape and other improvised materials to repair vital systems and conserve resources. Against all odds, the Apollo 13 crew returned safely to Earth, thanks to their ingenuity and the unwavering support of Mission Control. This event underscored the critical importance of rigorous training, meticulous planning, and clear communication in the face of adversity. Section 8. The future of space exploration towards safer journeys. As we venture further into the cosmos, ensuring the safety of our astronauts remains paramount. NASA and other space agencies are constantly working to improve spacecraft design, develop more efficient propulsion systems, and enhance emergency procedures. Advancements in artificial intelligence and autonomous navigation hold great promise for future missions. These technologies could enable spacecraft to identify and respond to potential dangers more effectively, potentially mitigating risks before they escalate. Furthermore, the development of advanced life support systems capable of recycling air and water would reduce dependence on Earth-based resources, making long-duration missions more sustainable and less risky. Section 9. Conclusion. A universe of challenges, a future of solutions. Space exploration, while inherently dangerous, is driven by an insatiable human curiosity and a desire to push the boundaries of knowledge. While the challenges are many, the ingenuity and resilience of those who dedicate their lives to this endeavor offer hope for a safer future among the stars. Through rigorous training, meticulous planning, and constant innovation, we can mitigate risks and ensure the well-being of our cosmic pioneers. As we continue to explore the universe, we do so with the understanding that every mission is a testament to human courage, ingenuity, and our unwavering pursuit of knowledge.